All right, for our research scenario section of our review, we're mainly looking at variable identification and then choosing a statistical test given a certain amount of information. So our first research scenario says that a study is looking to see if there is a difference in long-term strength gains as measured by a 1RM bench test by adding high-intensity interval training to a weightlifting program. Subjects were split into two groups, weightlifting only and weightlifting plus HIIT. 1RM bench press measurements were collected after 12 weeks of training. So, the first thing we're going to do is identify our independent variable, classify what type of data it would represent, and then note if it's a within or between subject factor. So the main manipulation that we're looking at in here is the type of program that a person is doing. So that's kind of outlined in this section here, right? So training program might be our independent variable. And it does have two levels if you want to go as far as to break that down, where we had weightlifting versus weightlifting plus our HIIT training. Okay. As far as the type of variable, since we have two mutually exclusive categories, we would say that this would be nominal data. And we've also identified that subjects were split into two groups, meaning that the people included in one group were not included in the other group. So that tells us that we have a between subject factor for our independent variable. Okay. For our dependent variable, the measurement that we were collecting is long-term strength gains or strength gains. So either one of those is acceptable. Okay, and we measured that using the 1RM bench test. Okay, or like a 1RM bench press test. So if you also put that as like the variable that's measured as a means of getting strength gains, that would have also been an acceptable answer. And the data we collect for that is ratio data. Okay. So based off of this information, knowing that we have a nominal independent variable with two levels, it's a between subject factor, we could consult our decision tree, right, where we've got parametric dependent variable, that's our strength gains. Our independent variable is non-parametric, and we have two levels of that single independent variable. The main difference between independent and paired is the between versus within subject, and we identified we had a between subject variable, so that should tell us that we're running an independent t-test. And I can't spell. Okay. So then this question is asking to write out the null hypothesis for the main effect of the test. So the null hypothesis for an independent t-test would be that in terms of the variables used, okay, so generically we would say there's no effect of the independent variable on the dependent variable, which I'll pretty much keep as my format for this one. So in this case, type of training program has no significant effect on strength gains. Okay, and that would be our first example. Our second example is looking at annual income and cardiorespiratory fitness. So a researcher wants to examine the relationship between annual income and cardiorespiratory fitness. A random sample of 50 people self-report their annual income in US dollars via a survey. Subjects are then put through a VO2 max test to quantify their cardiorespiratory fitness. So what type of data would annual income represent? First of all, there's a key word in here that we're looking at a relationship. So if we go back to our decision tree, we can see that when we have a correlation, both our dependent variable as well as our independent variable should be parametric data or ratio. Okay, so that's kind of a dead giveaway as to the type of data that annual income would be. It should be ratio. And then cardiorespiratory fitness, if we're looking at a relationship between variables, should also be ratio or parametric. Okay, so again, because we were looking at a relationship, this would indicate that we are most interested in a correlation. For your guys' exam, because we have two different types of correlations, you need to be specific about the type of correlation. So if you wrote correlation, that would give you a half credit. When we look at our research design, we have two variables of interest. So we would most be interested in running a bivariate correlation. Yes, okay, sorry. I had a thought. We would be most interested in running a bivariate correlation to assess a relationship between two variables. So the null hypothesis for a bivariate correlation is that there is no significant relationship between our two variables, right? So in this case, it would be between annual income and cardiorespiratory fitness. Respiratory, I always have to say that to spell it. Okay. Now, what if we changed our scenario and said what type of statistical tests would be used if we wanted to see if cardiorespiratory fitness predicts annual income? Recall that when our goal shifts from looking at just a relationship to actually predicting a certain variable, we would end up being interested in using a regression. So again, if you only write regression, that's half credit. You would need to specify that since we have two variables, we would be running a bivariate regression. And that would give you full credit. Okay. So from that, we know that the null hypothesis is going to change slightly. And specifically, we're seeing if cardiorespiratory fitness predicts annual income. So that means our null hypothesis would be that cardiorespiratory fitness is not a significant predictor of annual income. Okay, or that your independent variable in your regression is not a significant predictor of the dependent variable or the variable you're trying to predict. Okay, so there will be various examples. I just gave you guys two to work with here. And in our next video, we'll go through reading and interpreting SPSS outputs. I'll actually put each of the tests that we go through in a separate video. That way there's a bit of an easier reference instead of running through a large video altogether.